misconception is that a volcanic eruption is the most likely thing to occur in the Yellowstone region on the timescale of a human life.
This restless Yellowstone Caldera is truly living, breathing, and every once in a while it burps.
Within the heart of America's untamed wilderness, a hidden world of wonder and danger lies beneath the surface of Yellowstone National Park, a land of mystery and awe. But what if we told you that beneath this natural paradise lies a ticking time bomb? A supervolcano that could rewrite the course of human history with a single eruption. In this gripping expedition, we'll venture deep into the heart of Yellowstone, exploring its geysers, unraveling the secrets of supervolcanoes, and uncovering mind-blowing discoveries that could change everything we know about our planet. Join us on this epic journey as we dive into the heart of one of the most geologically active places on Earth, where the forces of nature are breathtaking and terrifying. Yellowstone Caldera. First and foremost, it's essential to grasp that Yellowstone is not just a park. It conceals a colossal volcano, one of the largest active volcanoes globally. Classified as a supervolcano, its eruptions can be thousands of times more powerful than typical volcanic outbursts. The Yellowstone Caldera, a massive depression, is the result of the most recent of the park's 3 super eruptions over the past 2.1 million years. The first of these eruptions occurred exactly 2.1 million years ago, creating the Huckleberry Ridge Tuff and leaving behind a caldera exceeding 60 miles in width. Subsequently, the second eruption 1.3 million years ago produced the Mesa Falls Tuff and Island Park caldera. The most recent significant eruption, which led to the Lava Creek Tuff and the present-day Yellowstone caldera, happened around 640,000 years ago. This eruption discharged a staggering 240 cubic miles of rock, ash, and volcanic gases into the atmosphere, causing a global temperature decline and reverberating impacts on ecosystems worldwide. Imagine a force so massive it could wreak havoc on a planetary scale. Yet, the narrative doesn't end here. Yellowstone Earthquakes. Yellowstone has recently taken the stage for a seismic spectacle, capturing the interest and concern of both scientists and the general public. The potential for such a supervolcano to erupt is a matter of grave importance, and understanding its magnitude and historical activities is crucial for comprehending the potential risks it poses to the world today. Meanwhile, in the northern reaches of Yellowstone Lake, a fascinating series of seismic events has recently unfolded, catching the attention of experts. It all began on March 28th with what seemed like a minor magnitude 0.7 earthquake. However, what followed was truly extraordinary. Within just 12 hours, a remarkable earthquake swarm commenced. In less than a day, an astounding 60 earthquakes, ranging in magnitudes from 0.1 to 3.7, made their presence felt. But there's more to this story. According to the U.S. Geological Survey and the University of Utah seismograph stations, July 2023 was another noteworthy month in the Yellowstone National Park vicinity. Among the 88 earthquakes detected, the most significant event was a minor earthquake with a magnitude of 2.2. It occurred about 14 miles to the north-northwest of the lake, well within the boundaries of Yellowstone National Park, precisely on July 25th at 8:52 p.m. Records show that since 1973, the Yellowstone region has experienced over 48,000 earthquakes within its expanse. Astonishingly, 99% of these quakes registered magnitudes of 2 or below. Annually, this park witnesses an astonishing average of around 1,500 to 2,500 earthquakes. These seismic events add another layer of interest to Yellowstone's already compelling geological story. Surprisingly, the majority of these earthquakes went unnoticed by humans due to their minor intensity, but were swiftly detected by a sophisticated network of about 50 seismometers, aptly named the Yellowstone Seismic Network. In reality, seismic activities in the Yellowstone region are relatively common. Approximately 50% of all seismic events in the Intermountain West region are linked to Yellowstone. One such notable event is the Hebgen Lake earthquake, a seismic event of great magnitude. It ranked among the mightiest ever recorded in North America, rivaling the destructive impact of the San Francisco earthquake, boasting a magnitude of 7.3. Tragically, the Hebgen Lake earthquake resulted in the loss of 28 lives. Many of these casualties were due to a massive landslide that propelled a staggering 180 million tons of rock, mud, and debris into Madison Canyon at astonishing speeds, reaching up to about 100 miles per hour. This force generated winds comparable to a hurricane. The impact of this landslide was so profound that it led to the formation of Quake Lake. In addition, the seismic upheaval in Yellowstone left an indelible mark on the park's geothermal features. The Yellowstone National Park. America's very first national park stands as a global trailblazer. This immense sanctuary sprawls across 2.2 million acres, stretching through Wyoming, Montana, and Idaho. Within its borders, Yellowstone safeguards a remarkable assortment of over 10,000 hydrothermal features, including hot springs, mud pots, fumaroles, and geysers. Interestingly, Yellowstone is the proud host of more than 500 active geysers, constituting over half of the world's geyser population. But it's not just a hotbed of geothermal wonders, it's also a wildlife haven. Home to a diverse community of animals, the park boasts over 67 different mammal species, including the majestic grizzly bear, elusive wolves, and herds of bison and elk. What makes Yellowstone truly enchanting is its unique blend of geological wonders and thriving wildlife, making it an irresistible magnet for tourists. Every year, millions of visitors are drawn to this extraordinary park, seeking to immerse themselves in its natural wonders and wildlife encounters. However, amidst the captivating beauty of this scenic landscape lies an intriguing and often unnoticed reality. Scientists have recently unearthed a significant revelation about Yellowstone's supervolcano, a discovery that is poised to challenge our existing beliefs. Stay with us till the end for a fascinating journey into this newfound understanding. Norris Geyser and Steamboat Basin. Meanwhile, within the heart of Yellowstone's oldest thermal sanctuary lies the Norris Geyser Basin. This scorching region boasts thermal wonders that have been simmering for a staggering 115,000 years. The temperature here can soar to a mind-boggling 459 degrees Fahrenheit, just 1,000 feet beneath the Earth's surface. But that's not all. Within this searing landscape, you'll encounter the majestic Steamboat Geyser. This towering giant, standing at 400 feet tall, serves as proof of Yellowstone's ever-changing terrain. In the past, it was a rare spectacle, erupting sporadically with unpredictable intervals, ranging from 4 days to an astonishing 50 years. But then a game-changer arrived on March 2018. Steamboat began to showcase its grandeur more frequently, sometimes erupting once a week. In 2018 alone, it erupted 32 times, shattering previous records. It outdid itself the following year with an astonishing 48 eruptions. This leaves us wondering, could this increased activity be linked to a sudden 320% rise in eruption risk? Indeed, the Steamboat Geyser's unpredictable antics are just a fraction of the intriguing tale. Scientists are engrossed by the rhythmic dance of the basin itself. Over 8 years, starting in 1996, an 18-mile stretch of land rose by almost 5 inches, only to dip down by nearly 3 inches in the subsequent 8 years. Then, almost out of nowhere, it surged up again at an astonishing pace of almost 6 inches per year. In March 2014, a formidable 4.9 magnitude earthquake rocked the basin, halting this relentless uplift. Since then, the ground has oscillated between sinking and rising until 2019, when it finally began to descend. Presently, the basin stands proud, about 5 inches taller than it was in 2000. But could there be another factor contributing to this 320% increase? The hint lies in the term supervolcano. A supervolcano means superdestruction. An eruption of this magnitude under Yellowstone National Park would be unparalleled, unlike anything the world has ever witnessed. The very landscape we marvel at holds a powerful secret, and the Steamboat Geyser's behavior might just be a sign of something much greater lurking beneath the surface. Let's uncover the mysteries and the potential risks tied to Yellowstone's supervolcano. The supervolcano. A supervolcano means superdestruction, and an eruption beneath Yellowstone National Park would be unlike anything the world has ever witnessed. There are 20 supervolcanoes on Earth, posing the biggest natural threat to human existence. Yellowstone's supervolcano, despite scoring an 8 out of 8 on the Volcanic Explosivity Index, has only erupted 3 times in the past 2.1 million years. But the fourth eruption might be closer than you think. The most recent eruption, which occurred 640,000 years ago, serves as a chilling reminder. Volcanologists warn that when it happens again, the explosion will release toxic gases, destroying crops and disrupting electricity supplies to the Midwest. The United States would then endure insanely cold temperatures, as a poisonous cloud would block the sun for years. According to the European Science Foundation, it would be the greatest catastrophe since the dawn of civilization. Adding to the concern, cracks have begun to appear. In 2018, Grand Teton National Park in Wyoming closed due to a massive crack, leading to the closure of Hidden Falls and Inspiration Point for safety reasons. Park rangers carried out a risk assessment process underlining the growing apprehension surrounding the supervolcano's potential for eruption. The stakes are high, and understanding the risks and being prepared is paramount. According to a source at the U.S. Geological Survey, the rock face crack is a common risk associated with rockfalls. Yellowstone's supervolcano, which unleashed a cataclysmic eruption hundreds of years ago, spewing 240 cubic miles of rock, ash, and volcanic dust into the sky, also left a massive 34 by 50-mile depression in the ground. Remarkably, this geological giant lies in proximity to Grand Teton National Park, where the recent discovery of a 100-foot-wide crack in the supervolcano in Yellowstone has raised concerns among experts and visitors alike. Now, it's time for today's subscriber pick. In the heart of Yellowstone National Park, where geysers hissed and bubbling mudpots spat their defiance at the calm surface, a group of intrepid scientists embarked on an extraordinary journey as Yellowstone Park just shut down and the risk of sudden eruption increased by 320%. They were on a quest to unlock the secrets of Yellowstone's geysers and the supervolcano that lay beneath. Dr. Emily Turner, a brilliant geologist, led the team. She had always been fascinated by the volatile beauty of Yellowstone. With her were a diverse group of experts, seismologists, geochemists, and biologists, all brought together by their shared curiosity and a touch of audacity. Their journey took them deep into the heart of the park, where they descended into a labyrinthine network of caves and tunnels, a hidden world beneath the geyser's surface show. As they ventured further, they stumbled upon a breathtaking discovery. In a cavern adorned with shimmering crystals, they found evidence of an ancient civilization that had lived beneath the park, harnessing the power of the geysers for their energy needs. Their excitement grew as they realized that the civilization's fate was tied to the supervolcano. Dr. Turner theorized that the geysers were not just nature's spectacle, but also a crucial part of the volcano's pressure relief system. The ancient people had known this, and their intricate tunnel network had allowed them to manage the volcanic pressure. As the team pieced together the puzzle, they uncovered clues about the volcano's behavior and found a way to predict its future eruptions more accurately. Their discovery would revolutionize the field of volcano monitoring worldwide. Back on the surface, the team shared their findings, leaving their mark on the history of geological science. Yellowstone's geysers and supervolcano were no longer just a spectacle. They were a living laboratory, proof of the endless wonders of Earth's mysterious depths. The world marveled at the audacious journey of Dr. Turner and her team and the secrets they had unearthed from the belly of the beast beneath Yellowstone. But do you think these discovered clues could eventually avert this supervolcano eruption that the entire continent of the U.S. would be covered with ash? Please share your thoughts on this matter. Supervolcano threat. Supervolcanoes are catastrophic threats, similar to asteroids, nuclear conflict, or biological warfare, capable of devastating humanity. However, the gravity of this danger often goes underestimated. Aviation accidents may claim lives each year, but they'll never wipe out 10% of the world's population in a single crash. In contrast, supervolcanoes, like the one lurking beneath Yellowstone National Park, could cause unparalleled destruction. Remarkably, although Yellowstone became a national park in 1872, scientists only fully grasped the size of the volcano in the 1960s. It wasn't until the 1980s that they recognized it as a living, active threat capable of a catastrophic eruption. Yellowstone's eruptions can be thousands of times more powerful than the 1980 Mount St. Helens explosion. In such an event, several feet of volcanic ash would blanket the northern Rockies, enveloping nearly the entire United States in a grim shroud of ash and darkness. The unsettling truth is that we possess the means to mitigate these catastrophes, but we often neglect them, exposing ourselves to unforeseeable dangers. The Federal Aviation Administration allocates over $7 billion annually to aviation safety, yet comparatively little is directed toward addressing the looming threat of supervolcanoes. As we bask in the beauty of Yellowstone's natural wonders, it's crucial to acknowledge the formidable force beneath our feet and the need for vigilant monitoring and preparedness. The potential consequences of a supervolcanic eruption are profound, and our understanding of these geological giants must drive us to action rather than complacency. The hidden Yellowstone architecture. Meanwhile, geologists are on a quest to uncover the secrets lying beneath Yellowstone's iconic hot springs and geysers. Their burning questions remain. Will Yellowstone erupt again? When might it happen? And how devastating could it be? A colossal eruption is a low-probability, high-consequence event, similar to the mythical Black Swan, capable of profoundly impacting both society and the Earth. While not certain, it's not ruled out either. For scientists, the challenge lies in the rarity of such supervolcano eruptions and the hidden complexities. The critical information is buried kilometers beneath the surface, concealed within a labyrinth of chaotic forces, intricate chemistry, and enigmatic geological features. Recent revelations emerged from a research team's simulation of the volcanic underworld beneath Yellowstone. They unveiled a hidden architecture where molten lava ascends from Earth's core, forming two colossal chambers of partially melted rock beneath the park's surface. These chambers, one atop the other, are separated by non-melted rock. The lava flowing from Earth's mantle is relatively gas-free, but it cools and hardens when it encounters the relatively cold crust, forming a layer approximately 6 miles beneath the surface. Above this lies the upper magma chamber, filled with thick, explosive magma brimming with gas. It's similar to a shaken, unopened soda can, teetering on the edge of a fizzy explosion, a volatile mixture with the potential for immense force. The new discovery. In a recent study, scientists delved into the fascinating geological makeup of Yellowstone, explaining how its intricate two-tiered structure came to be. This detailed investigation, published in Geophysical Research Letters, sheds light on the evolution of this geochemically diverse architecture over time. The researchers envision a future where they can capture a model snapshot, revealing the system's appearance after significant melting triggers a major eruption. Their model provides a unique window into the past, enabling them to estimate how eruption rates might have been affected millions of years ago. This latest discovery aligns with earlier research on Yellowstone's twin magma chambers lying beneath the park's surface. Geologists, employing advanced techniques, also measured the speed of seismic waves from mild earthquakes as they traversed through the partially melted rock structures. This data allowed them to create an MRI-like image of the two magma chambers, offering valuable insights. It's important to clarify that supervolcano is not a technical term. Yellowstone is accurately described as a caldera, referring to a volcano that forms a substantial crater due to massive eruptions, often devouring mountains in its path. Indeed, the outline of Yellowstone's most recent caldera, displayed on visitor maps, showcases a central region devoid of mountains, either submerged or obliterated by past eruptions. The volcanic history of Yellowstone is staggering, with the first major eruption occurring approximately 2.1 million years ago, and the most recent about 630,000 years ago. There's a heightened concern now, with a 320% increased risk, possibly signaling the approach of the fourth major eruption. However, predicting the exact magma threshold needed for a caldera-forming eruption remains uncertain, yet Yellowstone is far from dormant. Relatively minor eruptions that produce lava flows are quite frequent, with the most recent occurring around 70,000 years ago. The potential for a catastrophic eruption remains a reality, underscoring the need for ongoing monitoring and research within the Yellowstone system. Possible super eruption at Yellowstone. The mere thought of a possible eruption within Yellowstone National Park sends chills down the spines of those who know the area's remarkable geology. Such an eruption would be an unimaginable catastrophe, surpassing any known disaster. In the immediate aftermath, the landscape would be scarred by destruction, buried in ash, and overwhelmed by fiery surges and flowing lava. This cataclysmic event would spare nothing, wiping out the park's breathtaking vistas, its diverse wildlife, and the iconic geysers that have captivated generations. But the devastation wouldn't stop at the park's borders. Nearby towns and communities would face catastrophic consequences, and evacuation efforts would be met with immense challenges. According to one model's projections, the fallout from a super eruption in Yellowstone could cast a dark shadow over 3/4 of the United States. A chilling estimate suggests that up to 90% of people within a 1,000-kilometer radius of the epicenter might meet a tragic fate. Among the most haunting spectacles of such an eruption would be the colossal ash cloud it would generate. This massive cloud could potentially shroud vast swaths of North America under a thick, suffocating blanket of ash, plunging the continent into darkness and chaos. The sheer magnitude of such an event is difficult to comprehend, and the consequences would be felt far and wide. The grim scenario we face hinges on the release of an astounding amount of volcanic material, measuring thousands of cubic kilometers into the upper atmosphere. To compound this impending calamity, colossal quantities of volcanic gases and aerosols would be unleashed, creating a global impact that would forever alter our climate. The formation of a stratospheric aerosol layer, primarily composed of sulfur dioxide and various gases, could act as a shield, deflecting sunlight and inducing a significant cooling effect on the Earth's surface. In a chilling forecast, analyses suggest that the aftermath of a Yellowstone super eruption might lead to an annual drop of up to 12 degrees Celsius in global temperatures. This onset of a volcanic winter would send ripples through intricate weather patterns, resulting in reduced agricultural yields and, consequently, triggering food shortages in various corners of the world. The reverberations of such a catastrophic event would be felt far and wide, underlining the critical importance of monitoring and understanding the potential hazards that lie dormant beneath our feet. Geysers that had lain dormant for years suddenly burst into life, while the patterns and behaviors of others underwent dramatic shifts. Notably, the intervals between eruptions of the renowned Old Faithful geyser changed, and new hot springs and fumaroles emerged within the park. This event prompted a thorough re-evaluation of the seismic hazards inherent to the Yellowstone region, leading to substantial improvements in monitoring and response protocols. The recent surge in seismic activity has reignited discussions and concerns regarding the possibility of a significant seismic event occurring within the park's boundaries. With an annual tally of between 1,000 and 3,000 earthquakes, this region ranks among the most seismically active zones in the United States. While most of these tremors go unnoticed and have minor consequences, the recent swarm has raised legitimate concerns. The broader question looms. Are these tremors indicative of the Yellowstone supervolcano showing signs of an imminent major eruption? Or are they simply nature's unpredictable ways reminding us of its power? To truly understand the implications of recent events, it's imperative to embark on a comprehensive exploration of Yellowstone's intricate geological makeup. This national park sits atop a molten rock plume that ascends from the very core of the Earth. The geothermal wonders of the park derive their energy from this geologic hotspot, which is also responsible for the localized volcanic activities in the region. Interestingly, this hotspot deviates from the norm as it resides beneath the continental crust rather than the more typical oceanic crust. The recent surge of earthquakes occurring at the eastern edge of the Yellowstone Caldera, near the location of the most recent massive volcanic eruption, has ignited speculation about the possibility of a more substantial event on the horizon. Understanding the geological forces at play in this remarkable landscape is crucial for evaluating the risks and preparing for the future. Yellowstone wildlife's unusual behavior. Interestingly, within Yellowstone's varied animal population lies a potential source of insights. The park's landscapes are home to a diverse array of plant and animal species. However, recent times have seen some unusual events involving interactions between visitors and wildlife, particularly bison, resulting in distressing incidents. Reports include an individual being attacked by a bison and the discovery of a deceased woman on the Buttermilk Trail about 8 miles from West Yellowstone, suspected to be a fatal grizzly bear encounter. To ensure the safety of both humans and bears, the affected area has been temporarily closed off, while ongoing investigations work to unravel the circumstances. Within the scientific community, there's contemplation regarding potential correlations between wildlife behavior and recent seismic events. Some experts speculate that animals might possess a heightened sensitivity to phenomena imperceptible to humans. This notion isn't entirely new, as history has instances of animals displaying unusual behavior before seismic events, providing a fascinating avenue for further exploration in the context of Yellowstone. The relationship between Yellowstone's fauna and its geological wonders might be even more profound than we realize. The park's wildlife has evolved in harmony with its unique geothermal and seismic features, becoming an integral part of its ecosystem. Among them, bison have a remarkable connection to the land. They skillfully utilize the warmth from geothermal zones during harsh winters and adjust their migration patterns in response to local geological dynamics. Could the observed shifts in animal behavior be a response to changes occurring within the hidden magma chambers beneath the Earth's surface? Is it possible that these animals are attuned to environmental vibrations or chemical fluctuations beyond human perception? Scientists are passionately delving into these questions, striving to uncover potential connections between animal behavior and seismic observations. This exploration is an emerging frontier, a journey into the uncharted territory of the intricate interplay between animal instinct and seismic activity. The insights gained from this venture could potentially reshape our understanding of the natural world, revealing the astonishing ways in which animals adapt and respond to the geological forces that shape their habitats. Yellowstone's monumental discoveries. Recently, an extraordinary discovery has illuminated the enigmatic supervolcano nestled within Yellowstone National Park, unraveling its concealed mysteries. A team of seismologists from the University of Utah embarked on a daring exploration that unveiled a reservoir of scorching, partially molten rock, hidden at depths ranging from 12 to 28 miles beneath Yellowstone's supervolcano. To grasp the magnitude of this revelation, consider this. The reservoir's capacity surpasses a staggering 1,000 cubic miles, which is more than 11 times the volume of the Grand Canyon. This expansive subterranean pool dwarfs a shallower magma chamber that was previously acknowledged, but is now revealed to be 4 times larger than previously believed. This discovery signifies that the supervolcano beneath Yellowstone possesses a significantly greater quantity of magma than earlier estimates had indicated. Magma, the molten rock residing beneath the Earth's crust, emerges from the melting of rocks within the mantle or crust due to intense heat and pressure. It consists of an assortment of materials such as silicates, oxides, and sulfides. When this molten rock reaches the Earth's surface, it's referred to as lava. Expanding on their remarkable findings, a research paper published in the journal Science explains that this newfound magma is flowing at relatively shallow depths, playing a pivotal role in fueling past volcanic eruptions. The researchers employed a technique called seismic tomography to map the speed of seismic waves beneath the vast expanse of the Yellowstone volcano. This groundbreaking revelation not only deepens our understanding of Yellowstone's geological intricacies, but also underscores the need for continued monitoring and research. The cutting-edge 3D modeling of seismic waveforms is revolutionizing our ability to gauge the extent of molten material within Yellowstone's subsurface magma reservoir. This groundbreaking study suggests that Yellowstone's crustal magma reservoir holds an even larger volume of melt than previously believed, potentially reaching up to 20% melt at shallower depths. This is a stark contrast to earlier assumptions that projected a partial melt fraction, ranging from 5 to 15%. Importantly, this revelation does not indicate an imminent volcanic eruption. Ross McGuire, an assistant professor at the University of Illinois, underscores that there have been no signs of increased volcanic unrest within Yellowstone. However, understanding the volume and distribution of magma beneath the surface is critical for assessing potential volcanic hazards. Continuous monitoring of the subsurface becomes pivotal in providing an accurate assessment if conditions were to undergo substantial transformation. Recognizing the importance of proactive monitoring, the Yellowstone Volcano Observatory, in collaboration with other partners, has unveiled an enhanced volcano and earthquake monitoring plan. This initiative strategically deploys a network of instruments, including seismometers and GPS stations throughout the park, to provide real-time insights into the geological dynamics unfolding beneath the surface. By employing advanced technology and collaboration, scientists are not only expanding our knowledge of Yellowstone's volcanic system, but also enhancing our ability to keep a watchful eye on the ever-changing geological landscape. This proactive approach ensures that we are well prepared to respond to any potential changes and, most importantly, protect the safety of those living in and around this captivating and dynamic region. Over the next decade, we anticipate the introduction of innovative technologies aimed at enhancing the monitoring of geothermal activities and deepening our understanding of geological risks within the Yellowstone region. These advancements will bring valuable insights into the dynamic nature of this extraordinary landscape. Currently, authorities are actively working to ease public concerns, emphasizing that the recent seismic activities do not signal an imminent eruption. Instead, these earthquakes are likely a result of the movement of fluids and gases beneath the Earth's surface, a natural occurrence in a geologically active area like Yellowstone. These reassurances are essential to maintain a sense of security among visitors and residents. Which of these mysterious discoveries at Yellowstone did you find the most intriguing? Let us know your thoughts in the comments section below.